Hello everyone, our focus for this video is the sum and difference formula, right? But what we're really going to zoom in on is the sum and difference formula for tangent of an angle. Now in my previous video you would have learned about the sum and difference formula for sine and cos. But here on the board I have them as just a reminder, right? So sine of A plus or minus B is equal to sine A cos B plus or minus cos A sine B. And cos A minus R plus B is equal to cos B cos A plus or minus sine A sine B, right? So here there's just a point for you to note. If you are adding for the sine, then you add on this side as well. If you are subtracting, then you subtract on this side as well. For the cosine, that is slightly different. If you are subtracting, over here will take a plus sign. When you are adding over here, over this side will take a subtractant sign. Just a point for you to note. Now, here on the board, let's say that you are in an exam and they ask you to prove that tan A plus tan B is actually equal to tan A plus tan B, all of that divided by 1 subtract tan A tan B. How would you go about proving a question like this? Now I'm going to show you the approach that you can take to prove this question. One thing that we know an identity to be, from my previous video, to be that tan of x is actually equal to sine x divided by cos x, right? We know that. So now, if we are asked to find prove that tan A plus B is actually equal to tan A plus tan B, all of that divided by 1 minus tan A tan B, then we can use this identity, right? Now, if we apply this identity to what we are given, right, we're going to take this side, which is tan A plus B, right? Now, if we apply that identity that I just reminded you of, this is just the same thing as saying sine of A plus B, right? All of that divided by cos of A plus B, right? Now we know that tan A plus B is the same thing as saying sine A plus B divided by cos A plus B. Then we can expand this using the sum and difference formula for sine and cos, right? So what I am going to do, I am going to rewrite this here. So we know that tan of A plus B is equal to sine of A plus B over that. But what I'm going to do, I'm just going to expand it right out. So this is equal to, this is the same thing as sine of A plus B, all divided by cos of A plus B. That's what tan A equal to, right? I am going to write the expansion for this right here because my board is small, right? So this is the same thing as, can use this up here. So this is the same thing as sine of A, right, cos B, right, plus cos of A sine B, right? All of that divided by cos of B, cos of B, cos of A. Now remember, when it's cos, if you are adding, it's going to take a minus sign, and then it's sine of A sine of B, right? Now, after this, what do you think we can do? Now we know in our formula here, we have a 1 here. So that means where cos B, cos A is, I want a 1 there. How do you think I can get a 1 here? The only way I am thinking, what we can do is to divide all of this that we have here by itself. Because if you divide a number by itself, it gives you 1, right? So I can divide all of this by cos B cos of A, right? But this is the denominator. I'm also going to do the same thing to the numerator as well. I'm going to divide the numerator by cos of B sine cos of B cos of A, sorry. Right? So technically, if you note here, technically, cos B cos A over cos B cos A is basically just 1 over 1, right? So in other words, technically I'm dividing by 1 over 1, so I'm not really changing the problem, if you get what I mean. Alright? Now because I don't have the space here, remember that this part that I just erased is actually this part. So what would this equal to if I divide each term by cos B cos A? Now because I don't have the space, I am going to do it piece by piece so that you can see it. And then just write the result right here, right? So I place a bracket here, and this bracket means that I am dividing each term in the numerator here by cos B cos A. And also I am dividing each term in the denominator by cos B cos A. So let's take the first term in the numerator, which is sine of A cos of B, right? And I need to divide it by this term here, which is cos of B cos of A, right? What can cancel out here? Here I have a cos B here. So this cos B cancel out this cos B. So all I left back with is just sine of A over cos of A, right? That's what I left back with after dividing. But this here must ring a bell. What is sine A over cos A? That's an identity, right? Sine A over cos A is just tangent A. Can you see that here? So this is basically just tangent A. So instead of writing sine of A over cos of A here, I am just going to write what this identity represents, which is just tan A. So here, for the first term, I'm just going to end up with tan of A, right? Plus, now, I'm finished with this. I need to take the second term in the numerator here, which is cos of A sine of B, and I'm going to divide that by cos of B cos of A, right? What do you think is going to happen? Here, cos A is going to cancel out cos A here. What am I left back with? I am left back with sine of B over cos of B. But from the reciprocal identity, right? This ring a bell, right? You remember this identity that says tan of x is actually equal to sine x divided by cos x. So here I have sine B divided by cos B. That's just tan B, right? So this is actually tan B. So sine B over cos B is actually tan B. So instead of writing sine B over cos B, I'm just going to write tan B. So already it looks like I'm getting close to proving this thing. I already have the numerator already, right? So now I'm going to focus on the denominator here. Now I'm finished with this. Now I need to divide each term in the denominator by cos B, cos A, because I want a 1 here, right? So if I have cos B, which is this here, times cos A, all of that divided by cos B cos A, what's that give us? Anything divided by itself, that's just 1. So this is just equal to 1. Because cos B cos A divided by cos B cos A, that's just 1. Anything divided by itself. So this is just 1. So here I have 1. And this is minus, right? So I only have one term to divide. So now I am at this term, which is sine A, sine B. So now I am at sine of A, sine of B. And I need to divide that term by cos of B, cos of A, right? Can anything be cancelled out here? Now here I have sine A, I have cos A, I have cos B. Now, so nothing can be cancelled out here. So what am I going to do? What can I do? I can actually rearrange these because the numerator here is multiplying each other, right? And you know that multiplication is commutative, right? Because if I have 3 times 2, right? That is 6. Doesn't change the outcome. But what if I switch it around and I have 2 times 3? It's still 6, right? So here, I want to line up the terms with the a's beside each other or below each other, really. So what I'm going to do, I'm going to just rewrite this. So here, because this is multiplying, I can keep the numerator the same, which is a sine of A, sine of B, and I'm going to rearrange the denominator. And I'm going to write this, the cos A first. So I'm going to put cos of A times cos of B. Now that I have the A's over the A's, the B's over the B's, right? I can actually split this, right? I can actually split this. And if I split this, right? I hope you are following me. If I split this that I have here, I can write it as this because it won't change the value. This is the sine of A divided by cos of A times sine of B over cos of B. You follow me there? They are the same thing. Because how do you multiply a fraction? Numerator by numerator and denominator by denominator. So this is the same thing as this. Now that I split it, what is sine A over cos A? Sine A over cos A, that's just tangent of A. So this is just tangent of A. Times sine B over cos B, that's just tangent of B. That's just tangent of B. Right? And I can rewrite this without the multiplication sign, right? Because it's the same thing. So here, this term just boils down to be tangent of A, and I'm going to write it without the multiplication sign, so this is now tangent of B. Have I proved it? I think so. Here, they ask us to prove this, but I have done so. Right? So that's it. So that's a technique that you would use to prove the identity. So therefore, we know that tan A plus B is equal to tan A plus tan B, all of that divided by 1 minus tan A tan B. Alright? Now, let's just move into the second one. Here on the board I have tan A minus tan B, right? And I have a question mark. So I want to know the difference formula for tan A minus tan B. What I'm going to do, I am going to use the same technique that I just used to see if I can come up with the identity for this. Now, you would have known that tan of A minus B is the same thing as tan of is the same thing as sine of A minus B, all of that divided by sine divided by cos of A minus B, right? So this is equal to this. But can we expand this using the difference formula? Yes, we can. If we use the difference formula for sine A minus B, what would we get? Look up here. This is the difference formula. Sine A minus B, that's what's going to give us sine A cos B minus cos A sine B, right? So this is actually equal to sine A cos B, right? Because it's minus, it's still minus right here, and that's going to be cos of A sine of B. That's it. All of that divided by cos. Well, cos, what's it? For cos A minus B, that's what's cos B cos A plus sine A sine B. So we can use that identity. So this is equal to cos of B cos of A. Because it's minus, it's going to take a plus sign, right? And then it's going to be sine of A sine of B, right? Now, what are we going to do after this stage? Alright? What we are going to do, since this one seems to have a 1 here, we can use the same idea. We need a 1 here. Where cos B cos A is, we need a 1 there. So what can we do? If I need a 1 here, I can actually divide both the numerator and the denominator, divide both of them by cos of B cos of A over cos of B cos of A, right? So we divide both numerator and denominator, right? So if we're going to divide each term, again, I'm not going to do all of it in one. I'm going to just refer to it. So I'm going to take the first term here, which is the sine of A cos of B. Now I'm going to divide it by cos of B cos of A, right? Alright. Now, if I divide these two terms, here, clearly in the numerator I have a cos B. Clearly in the denominator I have a cos B. So this cancels out this. All I'm left back with is sine A over cos B. But you know what sine A over cos B is, right? That's just tangent of A. So all of this just work down to be tangent of A, right? So that's what's the first term here. Keep down my minus sign. Now I am going to take the second term in the numerator, right? So this is numerator. Second term in the numerator is cos of A sine of B. And I'm going to divide that by cos of B cos of A. Right? Again, what do I notice here? I notice here that I have cos A, right? And I have a cos A in the denominator as well. So this cos A in the numerator can cancel out this cos A in the denominator. All I'm left back with is just sine of B over cos of B. But what does sine B over cos B equal to? This is just equal to tangent of B. So this is the same thing as tangent of B. So I'm going to write minus tangent of B. Right? All of that over the denominator. And I'm going to repeat the process for the denominator as well. I'm going to take each term in the denominator. So I'm going to take the first term in the denominator, which is cos of B, cos of A, and I'm going to divide that term by cos of B, cos of A. What can cancel out here? Here in the numerator, I have a cos B. In the denominator, I have a cos B as well. Here in the numerator, I have a cos A. Here in the denominator, I have a cos A. So each of these are going to cancel out, right? So cos B is going to cancel out cos B. So this does leave 1 over 1 there. And cos A cancel out cos A. That's just 1 over 1. But what's 1 over 1? That's just 1. All of this just boils down to be 1. So my first term here in the denominator, that's just 1. Right? So that's what that is equal to. Now, keep my plus sign, and I only have one final step to do. I'm going to take the last term in the denominator here, which is this term, which is sine of A, sine of B, and I'm going to divide that by cos of B, cos of A. Again, maybe it's not easy for you to see it, so what you can do is to rearrange one of these, either the numerator or the denominator, right? So I'm going to rearrange the denominator since A comes before B in the alphabet. If I rearrange the denominator, I now have sine of A, sine of B, all of that divided by cos of A, cos of B, right? If I rearrange it, I can split both of them, right? And treat them as a separate fraction, right? So I can now write this as sine of A over cos of A times sine of B over cos of B. But what is each of these terms? Sine of A here, that's just equal to tangent of A. So this part here is the tangent of A. So this is just equal to tangent of A times what's sine B over cos B. That's just tangent of B. Right? I can now rewrite this without the multiplication sign. So here, I'm just going to put it here, which is just tangent of A times tangent of B. And that's it. I am finished. So now, I actually derive the identity or the formula, the difference formula for tan A minus B. So tan A minus B, therefore, tan of A minus B is actually equal to tan A minus tan B divided by 1 plus tan A tan B. Now, so when you look at both of them, for A plus B, here in the numerator you have a plus sign. In the denominator, you will have a minus sign. For A minus B, in the numerator you will have a minus sign, and in the denominator you will have a plus sign. So that's just the difference between both of them. Say that you're asked to calculate the value of tangent of 75 degrees. Right? Now, this is just two angles that you can add to give you 75 or subtract. If we have 30 plus 45, that's just 75, right? That's one way we can look at it, right? So, we're going to use these two angles. So this can be rewritten as tangent of 30 degrees plus 45 degrees. Agree with me there? Now I can use the sum formula, double angle formula for tangent, to expand this, and then that would give me tangent of 30 degrees plus the tangent of 45 degrees, all of that divided by 1, because plus is here, obviously this is going to be minus tan of 30 degrees times tangent of 45 degrees, right? Which is equal to, what is tangent of 30 degrees? Tangent of 30 degrees is 1 over root 3, or is just root 3 over 3, right? Plus tan 45. But what is tan 45? Tan 45 is just 1. So this is plus 1. Now, because I have a fraction in here, I'm just going to put a bracket here. Remember that this is the numerator, so I'm going to put this division sign, this long division sign, here. I'm going to open a bracket. So this is now 1 here, minus tan 30. But what is tan 30? Tan 30 is root 3 over 3 times 1, right? So that's basically what we have here. So this is just root 3 over 3, right? Can we simplify this? Yes, we can. Now, this is root 3 over 3. We can rewrite 1 with a denominator of 3 to be 3 over 3. That's the same thing. Because if we cancel 3 over 3, that's just 1. So all of that in bracket divided by, rewrite 1 here, this is 3 over 3 minus root 3 over 3, right? Now the denominators are the same, so we'll just simply add the numerators, put it back over the denominator. So we have root 3 plus 3, all of that divided by 3, divided by 3 minus root 3, all of that over 3. And again, keep the first fraction, so this is the root of 3 plus 3 all over 3, multiply by the invert of the last fraction. So this, if you invert this, this becomes 3 over 3 minus root 3, right? Now this, the 3 will cancel out here, so our final answer is just root, let me write the final answer over here. So final answer, tan 75 degrees is therefore equal to root 3 plus 3, all of that divided by 3 minus root of 3. That's it. Beautiful, right? Let's look at one more example. So, last one that we're going to look at is tangent. Let's see, they're asked to find the tangent of 105 degrees. Do you think this is equal to? Well, if you add 60 plus 45, that's equal to 105. Right? So this is the same thing as tangent of 60 degrees plus plus 45 degrees, right? Clear there? Then we can use the sum formula, right, for tangent to expand this to give us the tangent of 60 degrees plus the tangent of 45 degrees. All of that divided by 1 subtract tangent of 60 degrees times the tangent of 45 degrees. Alright? What is tangent of 60 degrees? Tangent of 60 degrees is root 3 over 1, which is just root 3. Alright? Plus tangent of 45, that is just 1. So that's all of my numerator there, right? All over 1 here, which is 1, minus tan 60 is root 3. So this is root 3 times what? Tangent of 45, which is just 1. So this can be simplified to be root 3 plus 1 all over 1 minus root of 3. Clear there? So therefore, tangent of 105 degrees is equal to root 3 plus 1 all divided by 1 minus root 3.